the quotient rule for exponents gives us a quick way to figure out the answer to problems when we are dividing bases that are the same. As you'll see here, x to the m power divided by x to the n power. Notice how the bases for both of those exponents are the same. They're both x. And when you have this situation, when you're dividing, when it looks like a fraction, then the answer is simply x to the m minus n power. You take these exponents and you subtract them. All right? So let's see how it works and why it works. So here's x to the fifth divided by x squared. All right? Well, x to the fifth, don't we know that that's really x times x times x times x times x, 5 of them, and x squared is x times x. Now, in what you know about fractions, if something on top of a fraction is exactly the same as the bottom of the fraction, they cancel out and leave you with ones, don't they? They turn into ones because they've canceled out. And so I can cancel out this x with that x. Oh, I can cancel out this x with that x, and I get another 1. And why that's important is 1 times 1 is just, 1. Well, what's left in this problem? Well, these are gone, and these are gone. The only thing left now are these 3 x's. X times x is x cubed. So that's how it works. Now look at this. What is 5 minus 2? It's 3. And so you don't have to go through this cancellation process to see what's left. You can simply take the exponents and subtract them. That's how the quotient rule, all right? So here's another example of division. Notice I have a base of x and an exponent, another base of x and an exponent. I've got this coefficient out here. Is there anything, on the bottom to kind of match? No, it's just kind of there, isn't it? And so I'm just going to leave it in my answer. All right, that 6 is going to be there. What am I going to do with this 6 and this 4, though? I'm going to subtract them, and the answer is going to be 6x squared. All right? We subtracted the x. Now I've got x's, but I've also got more coefficients. I've got a 12 up here and a 6 there. Well, that's just a fraction, isn't it? Are there any numbers that go into 12 and 6? Well, 2 does. So does 3. And if 2 and 3 go in, then 6 goes into both of those numbers. You could actually just say, well, 12 divided by 6 is 2. And that would leave you with a 2. Or you could say, I'm going to divide that by 6, and it turns into 1. And I'm going to divide that by 6, and it turns into 2. Now, I've got the coefficients taken care of. What happens when we take x cubed divided by x squared? It's x to the 3 minus 2 power, which is 1. And I don't have to write that. The answer is simply 2x. All right? If you write 2x to the first, you're not wrong, but you don't have to. Okay? Here's another one. Now we've got multiple variables and coefficients again. I can't just go 14 divided by 4. That doesn't come out evenly. But is there a number that goes into both 14 and 4? Yes, 2 does. So let's divide 4 by 2, and that turns into a 2, doesn't it? Let's divide 14 by 2, and that turns into a 7. So I know I've still got a 7 left up here and a 2 left down there. Now, what is x to the 5th divided by x? Okay, now be careful. Is there an exponent on this x? Yes, there is. It's a 1. X to the 5th divided by x to the 1st is x to the 4th, isn't it? And what happens right here? I've got y squared times y squared. Well, aren't those exactly the same? Aren't they going to cancel each other out? The subtraction you would do is 2 minus 2, which is 0, and we're going to find out in the next section that anything to the 0 power is 1. And so your final answer here is simply 7x to the 4th over 2. Okay? Good luck with exponents.